Alright, welcome back to another Roblox programming tutorial, and today we are talking about metatables part 2. Now, if you haven't watched my first video on metatables, please go check that out. And before you jump into this video, please make sure you are familiar with how tables work and dictionaries work. That is fundamental knowledge that you must understand before you jump into something that is, I wouldn't say advanced, but as complicated and as complex as metatables can be. So here's all the information from my last video, and just a nice little review here. Essentially, I was showing you how you can take a property and assign it to a metatable, and then essentially create a new table, which is an instance of this table, and print the value stored inside that table. If that doesn't make sense, please go watch my last video. I tried to explain it as best as I could there. Now, if you notice with objects, right, and object-oriented programming, objects are always defined by two things. Objects are always defined by the attributes that they have, their properties, and the behaviors that they have, their methods. So I'm going to go ahead and use a part here as an example, and notice that I have a new script here parented to this part, and I'll call this EX. Okay. So the basics of object-oriented programming is that you have objects, right? These objects are defined by the attributes they possess and their behaviors. So for example, a dog would have properties, and those properties would be like hair color, right? Eye color, fur type, and many other things. Then this dog also has behaviors. For example, it can speak, it eats, it sheds, which my dog sheds a lot, right? And so on and so forth. So these are the properties that make a dog what it is, and then these are its behaviors. Now, this is incredibly important for what we're about to talk about, because over here in the first video, all I did is I showed you the properties. Name would be a property. Very similarly to here, if I came down here and looked at the property here, I can change the property name here. And we talked about how these are child properties of this part. Well, the same thing here. Metatable is a child, or excuse me, new table is a child of metatable, where metatable has all the properties, right? And new table is just a new instance of that. The same way that part is just a new instance of a base class part, right? So that is really the example that I'm trying to draw here. So here are all its properties. Now, along with properties, if we go local part is equal to the script parent here, right? So I have now declared the script's parent to be the part I'm talking about here. Here are all the properties that I can access, and I would use a period to access all these different properties. I can also access behaviors that the part can do. Here are all the part's behaviors, and Roblox does a great job with this because all your behaviors here are in pink. So for example, a part can resize itself. You need to pass the part instance, you need to pass the amount here, a whole bunch of stuff you have to use. You can remove it. You can check to see if it's an instance of a specific class. You can find a child, you can get children of the part, you can clone it, right? There's so many different things you can do here, and these are all behaviors of the part, right? These are all functions that the part can perform, and that's what makes it an object, right? Those functions are very similar to how metatables do functions. So let's go ahead and look at an example. I'm going to create a new function inside of this metatable. So we're going to go ahead and do function. Now, when I create the function here, I'm going to type in the metatable's name. Very similar to how module scripts work, but we'll have metatable. And now I create a function, and here's where I can define a function of this, right? So I can say, tell me your name. And this is Pascal language here. I always recommend that when you start doing this kind of stuff, you start using the Pascal approach, which is essentially using uppercase after your first word here. So that way everybody knows that it's tell me your name, versus if you have like everything lowercase here, it's kind of hard to tell where the words like start and end. you know, I can't tell that this is me and then your and then name, right? So just small little thing here. All right, but I can do tell me your name, right? And I can go ahead and do this, and I can click enter, right? And I can do print. And now I'm going to use a keyword here that we're going to talk about a lot in a second, but I'm going to use the word self.name. Okay? All right, so what is this doing? What is this even talking about? How does this even work? Essentially, the way this works is that self is whenever this is called, right? Whenever this metatable is called, tell me your name, whatever calls it is the variable self. So self is whatever calls this, right? So in this case, if new table calls name, so new table does tell me your name, new table here is the variable self, right? Because new table is what's calling this to happen. So what's going to happen here is new table is going to perform the meta method, or the function here, not a meta method, but the function here, tell me your name. Tell me your name is going to look through new table to see if it has a property child name. Because new table has a metatable set here, it's now first going to check the metatable, which is right here, and since I created a property name here, right here, it's going to find this and go, new table does have a property of name, and that name is Anthony, right? So now new table can tell me a name, and as you see here, I'm going to go ahead and delete this stuff. It's going to tell me the name, and as you can see right here, it tells me the name. This is the idea behind having functions inside of your meta table, right? This is the whole concept. So now you have the ability to create properties, and you have the ability to create behaviors. So this could have been anything. This could have been speak, right? And it'll give me self.name. Now what's cool is I can come down here into here, and I can go new table. Here we're going to have to create a new instance here of metatable. We're going to do metatable, parenthesis, speak. And let's say if the metatable doesn't have a new instance of this table, let's say it says woof. Okay? Alright. But what's cool is now I can come down here to new table and I can change how that behaves. So instead of saying woof here, I can do new table, dot speak. New table, should be index speak is now equal to not woof, but arf, right? So now new table, I've taken this, which was originally designed in the metatable, but because new table has been set to this metatable, I had the ability to change these child properties from this to something I want, right? So I want it to be arf. Its base default is woof, but now I've changed it to arf. This is the exact same thing as coming over here. These are always set to brick color like gray stone, and material is plastic. When I do this here, that is the exact same as coming over to here. It's not exactly the same, but it's very, very similar as clicking this and changing the color. So its original default here is woof, but now I've changed it to a different color. And this is how you do this with metatables. Now, if I don't want new table to speak, right, I'm going to do speak here instead. So I'm going to go to new table, colon, speak, or new table, set the meta table, new table, colon, speak, parenthesis. Okay, now when I do this, I'm going to do self.speak. Right, and the idea here is that it's going to call, or I should say this as s, probably, that's probably where we're having a little issues here, self.s. So that's for the spoken word here. So it's going to go new table, it's going to perform the method speak here. When it does, it's going to look for self, the instance, whatever called this, which was new table, and it's going to look for the child property S, and it's going to print S, right? Because new table has been set to this metatable, it's going to come through here and look, and it's going to say, oh, metatable is here, right? But then it's going to realize I've set S, and I need to reset S here, to ARF. So it's going to say, oh, okay, here's the new value, and it's going to override woof here. If I didn't have this, it would just print woof. Now it's going to come back here and it's going to say, okay, I got it, and it's going to print ARF. Okay? So let's see this in action. But this is the whole idea of how you can use these metatables. So as you can see here, it prints ARF, right? And if I wanted that to change, and I didn't want it to print ARF, if I wanted it to print its base default value, then all I would do here is I would come delete this, and now it's woof. Okay, so let's go ahead and run it here. It printed ARF, but now it's going to print woof. And as you can see, it prints woof, right? And this is how metatables work. It looks complicated on the surface, but this is the whole idea. So now you have two things going on here. You have the ability to create, again, properties inside your metatable, right? Very similarly to how part has properties, right? Part can collide is a Boolean of true, right? You know, part is anchored, transparency, right? I can change all of these. But when I create a part, right, I can't change how that part loads. This part already loads based off of a set values here, right? This is just how a part loads, right? This is the exact same thing. When I have a metatable here, this is just the default of how the metatable comes. Its name is Anthony. When it speaks, it has woof, right? Now, whenever it's indexed, right, it's going to pass the metatable. And then you can also create functions for this metatable. So if I wanted this metatable to speak, say, you know, whatever it is here, it's normally going to say S, which is woof. But I can come in here, and just like I changed these properties over here, I can change those things. Just like I changed things in my other script that I deleted here, you know, when you had local part is equal to the script parent, I can change these things as well, right? So if I didn't want this to be 0, I wanted this to be 1, it's the exact same thing. Well, not exactly, but very, very similar. So this is the whole idea, again, as adding functionality to the tables. And this is what makes metatables so powerful, is normal tables and normal dictionaries store data. Metatables not only store all those properties, but now have functionality. And that's what makes them really special. So I hope this video was helpful. I hope this video made sense. I'll probably do a nice little metatable example in the next video to kind of show you how to actually practically use all of this. But if you have any questions, please feel free to leave a comment, and I will see you in the next one.